Today we're going to take a look at our first day of our quadratics chapter, and we're going to look at how to solve quadratics. So there are a total of 5 different ways that we're going to look at how to solve quadratics. And again, when we're solving them, we're looking for where does that cross that x-axis. Sometimes it might be twice, sometimes it might only be once, and other times it might not solve it at all. So one way you can solve is by graphing, by just taking a look at the picture. We're going to talk about factoring, completing the square, using the quadratic formula, and taking the square root of both sides. So the first method we're going to look at is factoring. And you guys will remember when we multiply binomials, maybe we have x plus 2 times 3x minus 1, and we distribute here, so we have 3x squared minus x plus 6x minus 2. So we say that equals, combined like terms, 3x squared plus 5x minus 2. Factoring is where we go from this back to multiplying those together. And the easiest way to factor is sometimes when you have like 2 terms, maybe we have 2x squared plus 3x, we look at what we can pull out of both terms. So each one we can pull out an x, so it becomes x times, well, if we divide out an x, we have 2x plus 3. Or let's say we have 8x cubed plus 2x squared. Well, what can we pull out of each term? Well, we can divide each by the number 2, but we can also pull out an x squared. So 2x squared, and then let's see, 8 divided by 2 is 4. We have an x left. 2x squared divided by 2x squared is 1. And you can always check by redistributing again. So that was our first way we factored. Another way we factored was we looked at what was called the difference of squares. And we said, well, if you have, let's say you have x squared minus 16, when you can take the square root of both those terms, it becomes x minus 4 and x plus 4. Because if you distributed this again, x squared plus 4x minus 16, you can see the positive and negative 4x, they sum to 0, so we're left with x squared minus 16. And it works anytime you are taking the difference of squares. So for example, if you had 4 minus 9x squared, you have 2 and 3x, so it would be 2 minus 3x and 2 plus 3x. So those were our easy ways of factoring. We're going to take a look at some where we have the 3 terms here, and you guys might remember this from the box and circle. And we're actually going to not only factor, we're going to solve these. So when you have that box and circle, when there's 3 terms, remember that you write these ax squared, bx, and c. On the outside, you multiply a times c, and you want numbers that multiply. You want 2 factors that multiply to ac, and they add to b. And then you put those numbers in here, and then you find the dimensions of the outside of your box. So this first one here, we have x squared minus 6x minus 16. So our a is 1. So 1 times negative 16 is negative 16. And then factors of it. Excuse me, sorry about that. If you are unsure about what we want things that multiply to negative 16 and add to negative 6, if you're not sure, you just list all the factors. And don't worry too much about the negative. So we got 16 and 1. Let's see, 8 and 2 and 4 and 4. Well, those we can make add to a negative 6 if we have it to be a negative 8. So they add to negative 6 multiplied to negative 16. So you have negative 8x and 2x. So we have x and x minus 8 plus 2. So this factors into x minus 8 and x plus 2 equals 0. And then to solve, we said each part equal to 0. So x minus 8 equals 0, x plus 2 equals 0. So we have x equals 8 and x equals negative 2. So let's try this next one. We have x squared minus 5x minus 14. So 1x squared, so a times c is negative 14. List out some factors, 1 and 14, 2 and 7, let's see, 3, 4, 5, 6, nope, so that's it. So negative 5, this would have to be negative 7. So negative 7x and 2x. So we have x and x minus 7 plus 2. So we have x minus 7 and x plus 2 equals 0. So to solve, x minus 7 equals 0, x plus 2 equals 0. Because anytime one of these parentheses equals 0, 0 times the other number will be 0. So you have x equals 7 and x equals negative 2. Solving with a coefficient, we do the same thing. The factoring, finding the dimensions of the box, the outside, is just a little bit trickier. But we write that in there. A times c is negative 15. Let's see, so we have 1 and 15, 3 and 5. Well, we can make 2 by negative 3. So we have negative 3x and 5x. And it doesn't matter where you put those. So now let's look at the first row. It's not just going to be x and x. What can we factor out of this first row? Well, we can factor out a 3x. So 3x and x. 3x times what gives you negative 3? Well, minus 1. X times what gives you 5? Positive 5. So we have x minus 1 times 3x plus 5 equals 0. And then set each parenthesis equal to 0. And solve. So we have x equals 1 and x equals, let's see, minus 5 divided by 3. So why don't you pause the video and try this next one. So let's see here, we have 6x squared, x and 2. A times c, that's 12. So we have 12 and 1, 2 and 6, 3 and 4. Let's see, but we need it to be positive 12. Oh, let's see. 12 and 1, 6 and 2, 4 and 3. If we did 2 negatives, so I'm going to say this one is not factorable. And let's double check. Let's take a look and see what this looks like on the calculator. Maybe I'm missing something here. 6 times 2 is 12, so our factors. 6 and 2, 4 and 3, so that makes the 1, but if it was negative 3, it would be negative 12. I'm curious to see what this looks like on the graph. Okay. So what do we have? 6x squared plus x plus 2. Well, that would make sense why it's not going to be factorable. It doesn't cross the x-axis at all. So we have a couple more where we need to solve. So why don't you pause the video and now try this one. So we got 9x squared, negative 12x, and 4. 9 times 4 is 36. Let's see, 36 and 1, 18 and 2, 12 and 3. There's a lot of factors here, 9 and 4, 5, 6 and 6. Oh, that makes 12. We can have them both be negative. So negative 6x and negative 6x. Let's see what multiplies to 9x squared. We got 3x and 3x, can factor out of that. So minus 2, minus 2. So we end up with 3x minus 2 times 3x minus 2 equals 0. And if we solve this, we got x equals 2/3. And those are the exact same. So when we take a look at the graph of this one, let's see. We got 9x squared minus 12x plus 4. You notice how it's just hitting the x-axis only once. It's what's called a double root. Now this last one, you might notice there's not 3 terms, but we can do difference of squares here. X minus 4, x plus 5 equals 0. So we have x equals 5 and x equals negative 5. Now the last thing we're going to look at is how to solve with square roots. So we could multiply this out and set it equal to 0, but if it's just a square root, we can take the square root of each side. So now we have x plus 5 equals 4, but when we're solving, we can also say it equals negative 4. And then we solve both of these, and we have x equals negative 1 and x equals negative 9. Now before we take the square root here, we're going to have to add 3 to each side. So now we have x minus 4 squared equals 3. We can take the square root, and it's not a nice integer number, so we can just leave it as the square root of 3 or negative square root of 3 and add 4 to each side. So you have x equals the square root of 3 plus 4 and x equals negative square root of 3 plus 4. Now this last one here, let's see, before we take the square root, we have to divide by 2. So we have x plus 3 squared equals 10. Now we can take the square root. So we have it equals positive square root of 10 and the negative square root of 10. Subtract 3 off of each side. So we have the square root of 10 minus 3 and negative square root of 10 minus 3. Now this last one, when we take the square root of each side, some of you guys might remember, and we'll talk about this later, when we have x plus 2 equals the square root of negative 3, and x plus 2 equals negative the square root of negative 3, we pull out an I. So that's x plus 2 equals 3i, because the square root of negative 1. So x plus 2 equals negative 3i. And if you don't remember the I business, don't worry too much about that. We'll go over this again. Just for some of you who are wondering about the negative, I wanted to remind you of that. We have those imaginary numbers. So minus 2 and x equals negative 3i minus 2. So the last thing we're going to look at, a rectangle has a length 3 centimeters longer than the width. And its area is 42 centimeters. Find its width. Well, we know area is length times width, so we know that equals 42. So we can distribute here x squared plus 3x equals 42. Set it equal to 0. And now we just have to factor this. So we have our x squared, 3x, and negative 42. It'll be a few minutes. If we multiply our a times c, we have negative 42. And we can start listing out those factors. 1 and 42, 2 and 21, 3, that divides in there. What's 42 divided by 3 is 14. 4 doesn't, 5 doesn't, 6 and 7. I must be missing one here. You guys see anything that I'm missing? Maybe this one is not factorable. Let's graph it and see. Let's see what we come up with. So we got x squared plus 3x minus 42. Well, it crosses. Let's see. 1, 2, 3, 4, 5. I wonder if it doesn't cross at a nice point. So let's see. Analyze graph, let's find a 0. 5.15, yeah, that's why we can't factor it. So this is one we'll talk about next time, and that we'd have to do with the quadratic formula. And we'll talk about that in about another day or two. So this one's not factorable, but you could solve it with the quadratic formula.